technology is impacting the construction industry like never before. From cloud-based collaboration and the development of digital twins, to robots, supermaterials, wearable tech, pollution-eating buildings, and even artificial intelligence, an incredible array of developments are helping to improve a sector that shapes how every human being on Earth is able to live their lives. These are the 9 construction technology trends to keep your eyes on in 2019. Rapidly moving from science fiction to reality, robots are beginning to enter construction in a number of areas. From autonomous rovers that can increase the efficiency and detail of site inspections, to mechanical arms that automate highly repetitive tasks like bricklaying and tying rebar, the robotic revolution looks set to gather significant pace in 2019. While the credibility of robots on live construction sites has long been questioned, the last 12 months saw a number of real-world trials deliver their results, and the unveiling of some astonishing developments. Now taken seriously, the debate has moved on to how best to integrate robots, the impact they will have on existing job roles, and the new skills that will be required as processes become automated. Building on this progress, the rise of artificial intelligence is also beginning to have an impact on construction. From the major leaps taken in concepts like predictive design at the project planning stage, to the rise of intelligent buildings that learn how best to operate themselves and serve their users over time, the construction sector will likely find itself at the core of the wider AI debate taking place across our societies in the year ahead. Though fraught with challenges and inherently disruptive, the rise of automation could give construction the efficiency, productivity, and safety breakthroughs it has sought for decades. Originally developed for military use and for patient mobility and rehabilitation, exoskeletons are now beginning to appear on construction sites. Helping to protect workers from manual handling injuries and the risk of hand-arm vibration, these mechanical suits that augment with human operatives can also deliver considerable gains in productivity. Already being rapidly adopted across manufacturing, live trials on construction sites in the past year have yielded results that look set to drive the development and uptake of exoskeletons in our sector during 2019. Connected job sites use cloud technology to make information about almost every aspect of their operation available to all the relevant parties, regardless of whether those parties are on site or elsewhere. From putting design information streamed from a single point of truth into the palms of operatives, to information by geolocation, remote site monitoring, personnel location tracking, live markups, and the seamless transfer of as-built information, connected job sites improve communication, productivity, and safety for everyone involved in a project. With the intuitive technology supporting these sites advancing and now more widely available than ever before, connected job sites are only expected to become more commonplace in 2019. Meanwhile, developments continue to be made in connecting people and consolidating systems through digital mapping engines that contain and visualize construction data. New technology like Bluebeam Atlas, set to be available in 2019, is leveraging geospatial mapping to rethink mobile information access. Mapping design and construction data onto a real-world job site, Atlas uses geolocation to present project information from multiple systems relevant to your physical location, making traditional folder structures obsolete and streamlining any access-critical process like snagging, inspections, and more. While autonomous vehicles continue to make headlines in the consumer space, their adoption in the construction sector looks set to take notable strides forward in 2019. As with the field of robotics, the automation of construction plant, particularly in relation to highly repetitive tasks, could greatly improve productivity whilst creating a safer work environment and helping to address the industry's shortfall in labour. At their electric site in Sweden, Volvo Construction Equipment trialled electric autonomous vehicles in conjunction with electric human-operated excavators to deliver a 40% improvement in efficiency as compared to a traditional setup. Other concept vehicles under development by the manufacturer include semi-autonomous electric excavators that can learn the careful movements required to achieve grading or highly accurate levelling. The combined use of autonomous technology and electric power enables work to take place around the clock, without the need for brakes or the disruptive noise levels that traditionally prevent such working. Meanwhile, Volvo's trucks business has made progress in developing a concept fleet of fully autonomous electric vehicles that can help combat pollution, noise and congestion in our cities by reducing emissions, planning optimum routes, and responding to real-time traffic situations. With growing awareness of the impact that construction has on our environment, technological advances are bringing numerous new material innovations to the fore. The recycling of hard-to-dispose-of waste products has seen a significant increase, particularly in relation to plastics. Recent developments have seen the incorporation of waste plastic into roadways and even its use as a material for 3D printing new building components or structures. CO2 is another byproduct being repurposed in an effort to reduce the carbon footprint of the industry. At this project in Atlanta, CO2 is injected into the concrete mix used in the building's structure. This carbon dioxide becomes trapped inside the concrete as it cures, while chemical reactions within the mix form limestone nanoparticles that increase the overall compressive strength of the final material. Staying with one of construction's most popular materials, self-healing concrete is mixed with calcite precipitating bacteria. These bacteria germinate when water enters the cracks in decaying concrete, filling the emerging air gaps. Other areas to watch include the continued rise of kinetic paving that harvests energy from the footsteps of pedestrians to generate electricity, 4D printed structures that have the ability to reshape or self-assemble over time by virtue of how different elements of their construction respond in differing conditions, and smog-eating buildings, coated in photocatalytic titanium dioxide that reacts with light to neutralize pollutants in the air of some of the world's most congested cities. Unmanned aerial vehicles, also known as drones, look set to become increasingly common on construction projects throughout 2019. From undertaking inspections, ensuring that operatives are kept out of harm's way, to surveying vast areas of land in just a few minutes, the continued rise of UAVs will considerably improve safety and productivity in construction. In a similar vein to robotics and the rise of automation, debate in this field has matured from one around feasibility to considering the steps needed for successful implementation, with safety, approvals, privacy, the need for suitable legislation, and the urgent demand for specialist skill sets all on the agenda. While virtual reality, or VR, has traditionally enabled project teams and stakeholders to step inside their proposed schemes before construction works commence, the technology is finding countless new applications across the industry as 2019 dawns. From enabling walkthroughs of complex site logistic plans in advance, to supporting health and safety awareness training, VR use has matured in construction and made a largely successful transition from its early days of novelty into a number of practical uses. In hardware developments, HP's virtual reality backpack PC allows VR users to enjoy a more realistic, untethered experience, adding to authenticity and improving outcomes. Meanwhile, developments continue to be made in augmented reality, or AR. The technology provides a digital overlay of our real-world view, offering a range of data to site personnel, from design information to statistics on productivity and health and safety warnings. The use of 3D printing technology is advancing rapidly in the construction sector at all scales. Accurate digital design information allows 3D printing to be used for everything from rapid prototyping, component manufacture and scale modelling, to the full-scale printing of house and bridge components. With a number of prototype structures completing in the past year, countless larger trials proving successful, and ambitious plans to 3D print entire housing districts in development, 2019 looks set to be the year that 3D printing moves from the fringes of construction to become a credible structural solution. The construction industry shapes our world, affects how almost every person on Earth is able to live their lives, and enables the majority of other businesses and service sectors to operate. In that context, ensuring that the built environment is operating as effectively as possible is of critical importance to the sustainability and successful development of the human race. By harnessing the data from the digitally enabled built assets we are now creating, our homes, offices, and in turn cities can all be operated in a smarter, more efficient, useful, and environmentally friendly way. Furthermore, the data arising can be used to assess trends and to inform the design of future buildings, infrastructure projects, and even large-scale citywide master plans. With the effective development of our urban environments on the agenda of countless governments and authorities around the world, we expect to see the importance of this area increase significantly in 2019. If you enjoyed this video and would like to get more from the definitive video channel for construction, subscribe to the B1M.